The shift introduced the key path to access a property of a instance. The instance can be a class or a structure. The properties of that instance can be accessed through KeyPath. Here the class user and properties are ID and name. The user, you create a user object. On this user object, through subscript, the name property can be accessed with KeyPath. The KeyPath for name is the class type and then property name. In the same way that ID property can be accessed on the user object through subscript with the key path, the class type is user and property type is properties ID. So this is the way, another way to access the properties through key path. The key path is itself, key path itself is a class type with generic types and root and value. So the key path from specific root and to this specific resulting value type. So as seen in previous example, the key path from a user model in user model and value is the result type and type of that name or ID. The class key path is extends the superclass partial key path. So partial key path class is value type erased, and it in turn it extends that any key path superclass, and that is the both root and value type erased. The key path can be assigned to a variable as it is the class instance type. So key path for the name property in user can be assigned to the name key path. So the type of the key path is can be a child class, that is a key path, and it can be a partial key path, that is a superclass instance, and this can be a superclass of that partial key path at any key path. In all these cases, that the name key path when you assign this, and this will have the both root and then result type, and partial key path and value type is erased and only root type, it will have the root type. So it is the most in any key path the both user and both root and value type is erased. So when you define a array like this, it can be a partial key path, so that only the elements of the array only the should be, it allows only the instance of that partial key path root type user. So when I define a partial key path of user, it only allows to add element to access the properties of the user. So any key path, it can be, if the array is defined as any key path, and that can be any root type and any property can be accessed. So let's see with some example. Before that, we see how to mutate an object. So how to mutate an object using key path. On that object, through subscript, provide the key path of that property and assigns the name. Here the key path must be instance of writable key path or reference writable key path. In Shift, there is a structures and there is a value type. The classes are reference type. When you create an instance with the let keyword, that is the constant. If it is the instance of the class, even though it is created with the let keyword, it's a constant, and that object can be mutable. If it is a structure, when it is created instance with the let keyword, that instance of the structure is immutable. So here it's created with the let keyword, but this is instance of the class, so this is mutable. And to mutate this name property of this object, and that since it is created with the let keyword as a constant, and that should be reference writable key path. If it is created with a var keyword, that is a variable, and that can be a writable key path. It's not necessary be a reference writable key path. It can be a writable key path. So when it is created with a let keyword, and if it is given as a writable key path, it gives the compile time error when try to mutate that property through key path. So the if created with the let keyword and created the instance of the class, that must be a key path, must be a reference writable key path. In Swift, the structures are value types. When you create an instance with the let keyword to the structure user, and that is immutable. So when you try to mutate the immutable object, even though key path is writable key path, and that gives the compile time error. To mutate a object of the structure, and that must be defined with the var keyword. So when it is defined with a var keyword and assigns instance of the structure, and that structure is mutatable, but the key path must be a writable key path. If it is not writable key path, and that compile time gives an error. So basically, so the conclude that, so keep that there is a writable key path and reference writable key path, and Swift has structures are value types and classes are reference types. When you create an instance with a let keyword, and that is the constant, and when you create an instance of the class with a let keyword, even though it is created with the let keyword, and that object is, since it is a class is reference type, and that object is mutable. So to mutate that object through key path, that key path must be defined with a reference writable key path. When you create with a var keyword, and that is a mutatable object, and so that can be either reference writable key path or writable key path works. So in case of structure, when you create instance of the structure with the let keyword, that is immutable. So if the name key path for the structure is writable key path, the reference writable key path only works for the class type. For the structure, it works only writable key path. Even though it is a key path is defined a writable key path, When I create instance of the structure with a let, that is immutable object, so that cannot be mutated, and compile time gives the error. To mutate an object of the structure, that must be defined with the var keyword, and the key path must be a type writable key path. And so let's see some examples of this. This is the JSONs of user, and then user, that's the user object. It has got the properties ID, name, and username. So address itself has got as an object that has got the properties, and company itself has an object and that's got the properties. So that is mapped to the model, and ID, name, and address is another class which has got properties. So to access a name property of the user model object, and this can be a name like this, and this can be chained if you want to access the name of the company. And so that is user model, and that instance variable company, and then within a company the property name is a name. In the same way, if you want to access the zip code, and it is user model, in a user model, and through address property, and zip code is a property of the address. So these key paths can be composite. So instead of chaining it, we can define the address key path, and then it can combine with the zip code key path. That is with append address key path append to the key path. So that is address model, zip code is key path. So when I use this key path with the subscript of that object of user model, it gives us a zip code. So this is the way to access. If we want to access the company name key path, company name of a user, and that we can provide that user instance, and then subscript with the key path. If we want to access the zip code, and zip code first address path, so address path for address property, and append the key path and zip code within that address model, so that can be provided here. So it displays zip code. So partial key path is the value type erased. So here it is, I here it is that the metadata, the uses some of that user data which is required by the application, I'll store in an array, that is user metadata, and that type array type is partial key path user model, so that the key paths for that properties are in the user model can only add it to this array. So add metadata key paths, that is the I need only name and username and address. So to print that metadata, I loop over it, and then get the property value of through key path. So these three key paths: name, username, and address. So here these key paths can be assigned to a variable, so that it can be defined as a instance of variables of local variables of that class or structure. And so look at here, the first user is the bread, and I am interested in the name, username, and username, a name and username, and zip code. So these key paths can be defined to can be used in the protocol too,